Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in today's video, we're going to take a look at how you can implement a circular queue using a single linked list. Now before we go ahead, in the previous couple of videos, we discussed how you can implement a queue data structure using a single linked list data structure. So please watch those because those are absolutely important, because a circular queue is just another variation of a simple queue data structure and it has some pros, and we've already discussed circular queue in previous tutorial as well. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Now in this tutorial, we're going to take forward the same code that we wrote in the previous tutorial. In the previous tutorial, we saw the queue using linked list, but now we're going to make it a circular queue. So first, let's just copy the entire code that we typed in the previous tutorial. By the way, if you've missed the previous tutorial, don't worry, I'm going to be sharing this entire code with you guys on our official website. So you can check that link in the video description. And of course, I'm going to explain you the code. We don't have to get into the theory because there is only a slight variation in a basic queue and a circular queue, which is implemented using single linked list, and I'll show you graphically on the screen also while explaining, so don't worry about that. So just open a new CPP file, let's save it. So I named our code circular queue using single linked list, and this is the same code of basic queue using linked list. So we are going to make some changes in this code, only a couple of changes required to make it work like a circular queue. Now before we proceed, let me just visually show you what a queue using linked list would look like. So as you can see on the top, this is a simple queue using single linked list where we have a queue data structure inside which we have some nodes. They are linked to each other in first in first out manner. You can see the front and rear. And now let's see a circular queue using same single linked list. Now you can see on the bottom we have a circular queue using single linked list only. Now the only difference here you can see visually is the rear node in the circular queue points back to the front of the node. So that's why it completes that circular loop. So the last node in the circular queue always points back to the first node in the circular queue. So N4, which is the last node in the circular queue, does not have null in its next pointer. If you observe N4 in the simple queue, it is null because it is not pointing to any other node. But if you observe the last node N4 in the circular queue, the address stored inside the next pointer of N4 is the address of N1. Okay, so that is visually the only difference. Otherwise, both of them are pretty much the same. And if you're wondering why do we require a circular queue, circular queue has certain advantages, especially when it is implemented using arrays. We've talked about it in the circular queue tutorial. You can check that out. But let's actually quickly see the code now to understand what differences and what changes are supposed to be made. We have to make very simple and minute changes. I'll explain to you what those changes are as well. But let's go ahead and quickly see the code now. On the top we have our basic hash include and using namespace, the basic boilerplate of any C++ program. Then we have the node class. Now the node class is going to be the same. It's not going to change. A node has a key, a data and a next pointer which points to the next node. The key part is not compulsory. Sometimes the implementation does not have the key part. The reason why we have a key in our node in our case is because when you want to uniquely identify a particular node, you can use the key. So in our implementation, we can write some code that every node will have a unique key. The data can be duplicate. This data is also known as value. So the value can have duplicate values. So N1 and N2 can have 100 and 100 as data, but the keys has to be different. Now this is not necessary, this is just the way our implementation is, and the reason, as I mentioned, is when you want to particularly find one particular node, you can use this key to search the entire queue and iterate through the entire list to find that particular node. Okay, so that's why we have 3 elements, and this is a single linked list, so that's why 3 elements. If it would have been doubly linked list, we would have got one more pointer as node previous pointer. And then we have the basic constructor, default constructor, as well as the parameterized constructor. We are going to mostly require the parameterized one. So this is node class. In the queue class is where we have to make the change, right? So this is a circular queue and not a regular queue. So I'm gonna write circular over here. Let's change the name to circular, and then the constructor also changes. Inside that, the two pointers front and rear are gonna be as it is, and when you create the object of circular queue, obviously initially the front and rear will point to null because we will not have any element or any node inside the queue. So this condition is gonna be as it is. Moving forward, the isEmpty function is also gonna be the same. The condition is if front and rear are pointing to null, that is if front and rear has the value null stored in it, it would mean that we do not have any node in the queue, and that's why it remains the same. Now as we move forward, the next utility function in the queue is check if node exists. So as the name suggests, this will search for one particular node inside the queue. Okay. Now this is where we have to do a little bit of change. Now this code will apply perfectly fine for a basic queue, for a simple queue, but not for a circular queue which has singly linked list inside it. So why is that so? Okay. So imagine that we have 4 nodes inside a circular queue. Now in a circular queue, obviously as I mentioned, node n4 which you can see is pointing to node n1, which means the next pointer inside n4 has the address of n1, right? So this check if node exists basically takes a node. Now this is the address of that node, so basically we are taking a pointer and we want to check if this new node which we want to probably insert, that is enqueue inside the queue, already exists or not. Because as I mentioned earlier, remember we cannot add more nodes in the queue if it has duplicate key. So if we have n1, n2, n3 and n4 already having the keys as 1, 2, 3 and 4 respectively, we cannot insert one more node n5 with the key of 4 or 3 or 2 or 1. It has to be something other than 1, 2, 3 and 4, right? So that's why we have to check before we actually enqueue that n5 node, this new n5 node. We have to check whether the key matches any of the key from the existing nodes inside the queue. That is what the whole purpose is of this function, right? So the first step over here is we say node star temp equals to front. So in our diagram you can see that we create a temp pointer of type node which is pointing to the front of the node. Now this is a circular queue, right? So temp will start pointing to n1, that is n1's address is stored in this temp pointer. The next thing we create exist equals to false. Now remember this while loop was used to iterate from n1 to n2 to n3 to n4. That is, we use this while loop to traverse through all the nodes inside the singly linked list, that is inside the queue. How does this work? We check while temp not equal to null. We say if temp of key equal to n of key, we say exist equals to true and we break out. Otherwise, we say temp equals to temp of next. Now if this was a regular queue where the last node n4 was not pointing back to n1, in that case this while loop would have come to a halt at the end of the node n4, because when temp will point to n4 and when we will say temp equals to temp of next, the next pointer in n4 would have address of null and that will be transferred into temp, right? So just to quickly iterate through the entire iteration, what will happen in a basic queue? Initially temp will start pointing to n1. We will say while temp not null, temp is not null because temp is pointing to n1. We will check temp of key, that is n1's key because temp is pointing to n1, equal to n of key. Now this n is this new n5 that we want to enqueue. Let's assume that we want to enqueue it, right? So n5 whose key is 4 is not equal to temp of key because temp of key is 1 because temp is pointing to n1. So this if block will not be executed. We will say temp is equal to temp of next. Now temp is pointing to n1. What is stored in n1's next pointer? It is the address of n2. So n2's address is now stored in temp. And then again this while loop will be executed because temp is not null because temp is pointing to n2 now. Similarly, this while loop will keep on executing till we reach the last n4, and when we come at n4, we will say temp of key, which is temp is pointing to n4, so n4's key is 4 is equal to n of key. Here n of key is basically 4 we are assuming. So this will have a match. We will say exist equals to true. Initially exist was false and we will say break and we will say return exist. So this check if node exists returns true or false, which means it checks if a node already exists with this particular key. If it exists, it will return true. Now imagine if it did not match, if n5's key was 5. So at the last match where temp of key is n4's key, imagine temp is pointing to n4, n4's key is 4, is it equal to n of key? No, because n of key is 5. So again this will not be executed, but we will say temp is equal to temp of next. Now for a simple queue, when temp is pointing to n4, the next pointer inside n4 is null. So null will be transferred to temp, right? And when we again come at the start in the while loop, we will check while temp not equal to null. But this time temp is equal to null. So that's why the while loop will stop working. Correct? So this mechanism, that is this iteration of nodes, that is this traversing of node n1 to n2 to n3 and so on, works with this logic for simple queue. But as I mentioned, in a circular queue, n4's next will be having the address of n1. So there would never be a case that any node has null in its next pointer, right? Because you can observe in a circular queue, n1, n2, n3 and n4, all of them have some address stored in their next pointer. So what would be the condition where this while loop has to stop? So when you come at the end of the node n4, n4's next pointer has the address of n1. So that should be the condition where you have to stop, right? Because then you will again start to iterate from the first node and this will be an infinite loop. So our while condition has to change and it has to be while temp not equal to front. So this is the condition, but again there is a problem over here. If you see the line number 49, the first thing that we do is node star temp equals to front. So we are already saying in the circular queue, we are creating a temp pointer, we are pointing it to front of the queue, that is the first node n1. So n1's address is stored in temp. Now this while loop will never execute because temp is pointing to n1. The condition inside the while loop is while temp not equal to front, which means when temp is not pointing to front, keep executing this loop, which means as soon as temp starts to point to this front, that is point to n1, you have to exit outside this loop. So we will never go inside this loop because of this one line of code. But logically, we have to stop after completely traversing from n1 to n2 to n3 to n4. So after n4 we have to stop. So we need some condition, right? So our logic is correct that this while loop has to stop executing when temp again starts to point to front, which means the first time it is pointing to front, it has to be allowed. Okay? And that's where the do while loop comes into picture. So just cut this, write do over here, and now paste the while over here. So that's the syntax of do while. And the difference between while and do while loop, I'm assuming you guys already know, but if you don't, do while loop is a exit controlled looping statement. So when I say exit control, it means that the condition is checked at the end and not at the start. So for the first time, even when temp is pointing to front, this do while loop will execute directly. So we will directly go inside the loop. We will say if temp of key equal to n of key. Temp of key is initially temp is pointing to n1, so n1's key is 1. Is it equal to n's key? What is n? N is n5, n5's key is 5. Is it equal? No. So if will not be executed, we will come outside if, and then we will say temp equals to temp of next. Now temp is equal to temp of next. Temp is pointing to n1. n1's next pointer has the address of n2. So n2's address is now transferred in temp. So temp starts pointing to n2. And now after this last statement in the do while loop, we will come at the end of the do while loop and now the condition will be checked. So now the condition is while temp not equal to front. So this do while loop will keep executing till temp is not equal to front. The first iteration, temp was pointing to the front, which is n1. So that's why we used a do while loop so that the condition doesn't get checked. Now you can see in the diagram, temp is not pointing to front, temp is pointing to n2, which is not the front. So that's why this condition will become true. That is, temp is not equal to front, which is true, right? Because temp is pointing to n2. So again, this do while loop will be executed. We will say, again, we will check temp of key equal to n of key. This time n2's key is 2. We will check with n5's key, which is 5. It is not equal. Again, we will say temp equals to temp of next. Similarly, we will keep on executing do while loop till we reach n4. Okay. When we reach n4, what will happen? Temp is pointing to n4. we will check n4's key, which is 4, is it equal to n's key, which is 5, no. Now we will say temp equals to temp of next. Alright, so in a circular queue, as I mentioned, n4 is pointing back to n1, which means the next pointer inside n4 has the address of n1. So temp is pointing to n4. So temp of next, which means n4's next, which is n1's address, is now stored in temp. And now when we check the while condition, we will say while temp not equal to front. Is temp not equal to front? No. This time the condition becomes false because temp has the address of n1 now. Front also has the address of n1 because front obviously always keeps on pointing to the first node. So now they are equal. So temp is equal to front and it is not equal to front, right? So now the condition becomes false and we completely exit outside this do while loop. That is where we break and we say return exist. So you can see for a circular queue using single linked list, the condition will remain the same, that is while temp not equal to front, but for the first time that condition will always be false, which means for the first time temp will always point to front because we will start from the front, right? So for the second time when we completely iterate and completely traverse through the entire single linked list, we will again come back at the front node, right? Because n4 or whatever node is at the end, be it n5, n6, n7, will point to n1 again. So again n1's address will now be stored in temp and that is where we want to stop. For the first time we want to traverse through the entire list, right? That is through the entire nodes. So that's why we're using a do while loop, because we don't want to check the condition for the first time. Because for the first time temp will always point to the front. We want to keep on iterating this loop till the temp starts pointing to the front the second time. And that's why the do while loop is used, and I know I'm reiterating it over and over again, but I hope I'm making some sense. If not, you can take a pen and paper and dry run this code. You can also visually make diagrams to better understand it. That's what I did on the digital side. But yeah, this is the minor change, that the while loop becomes do while loop. Let's scroll down. Now the enqueue function is pretty much going to be the exact same with a little bit of variation. So in enqueue we have first, if it is empty, that is if the entire queue is empty, we add the new node. So this is the node that we are passing. We say front equals to n, rear equals to n, because when we have only one single node in the queue, both front and rear are pointing to that same node and we say node enqueued. Then the second condition is the check if node exists that we just saw, which will return true if the node exists in the queue with the same key that we want to pass or that we want to enqueue. So if node exists, we say node already exists with this key value, enter different key, and hence we have the key in the node class. And in the else part, we want to enqueue this node. So imagine we have n1, n2 and n3 already, and we want to enqueue n4 with the key of 4. So here we say rear of next. So rear is pointing obviously to n3, right? You can see in the diagram. So rear of next we will say equals to n. Now since it is a circular queue, rear of next, that is n3's next, is pointing to n1 back. But that has to change because now the new rear is going to be n4 after it is enqueued. So we say rear of next equals to n, which is n4. So now the rear node, which was n3, now starts pointing to n4 because n3's next pointer stores the address of n4, right? So this is happening at this line. Then we say rear equals to n. So rear pointer was pointing to n3, that also has to change. It has to now start pointing to n4. So this n is this n that we are passing in this function, in the enqueue function, which is n4 as I mentioned. So rear equals to n will basically say that store the address of n4 inside the rear pointer. So now rear starts pointing to n4. And now the only thing you can see is we have to make the link of n4 back to n1 because it is a circular queue. So now we will say n of next equals to front. So front is obviously gonna keep pointing to n1 only because we are enqueuing a new node and enqueue always happens from the rear end. So there's nothing to be changed from the front end, right? So once we say n of next equals to front, the front's address, front is pointing to n1, n1's address is now stored in n of next. N of next is n4 of next. So n4 of next, which is the pointer inside n4, will point to n1. That is the address of n1 is now stored in n4's next. So that linking is happening now. So you can see the circular loop is completed. And again we will say node enqueued. Alright, so what happens in dequeue? So in dequeue also pretty much the process remains the same as a simple queue using singly linked list. If the queue is already empty, we will return null and we will say queue is empty. There is nothing to dequeue. Inside the else part, we have two conditions. That is, if we only have one element inside the queue, that is if front equal to rear, which would mean that we only have one node inside the queue. In that case, we have to dequeue that is remove that. So we will say temp equals to front, or you can say temp equals to rear because both of them are same in this case. So temp starts pointing to this one single node inside the queue n1, let's say it is n1, and then we will make front and rear null and we will say return temp. So this is gonna be as it is, nothing changes over here. Now in the else part, imagine if we have 4 nodes n1, n2, n3 and n4, n4 pointing back to n1 because it is a circular queue, and now we want to dequeue one element, and when we say dequeue, we want to dequeue from the front end, which is we want to dequeue n1. So now we will again say temp equals to front, temp starts pointing to front. Now we say front equals to front of next. So front was pointing to n1, n1's next is n2 because the next pointer inside n1 has the address of n2. So n2's address is accessed using this front because front is also pointing to n1, right? So when we say front of next, it would mean n1's next. n1's next has the address of n2. So that is accessed over here and it is stored back in the front pointer. So now front starts pointing to n2. So this is done. But now one last thing has to be done is, remember, the rear node, that is n4, is still pointing to n1. We have to dequeue n1. We have to remove it from this queue. Which means n4 now has to start pointing to n2 and not n1. So n4 pointing to n1, that link has to be broken. And n4 has to start pointing to n2. So what we will say rear of next. So we will access n4 using the rear pointer, and we will access the next pointer inside n4 using rear of next because rear is pointing to n4. So when we say rear of next, it would mean n4 of next, which is currently storing n1's address, and now we will say rear of next is this new front. We just made front equals to front of next, that is we just made front start pointing to n2, right? So n2's address is in the front pointer, that is taken and that is stored in rear of next, which is n4's next pointer. So now n4 starts pointing to n2. So that chain remains the same, and now we can simply return temp because temp has the address of n1 which can be removed off, right? So this one line extra is added over here, and that is the only simple change in the dequeue operation. Now in the count operation, again we use the while loop to traverse from n1, n2, n3 and n4. So that has to be converted to a do while loop. So we'll cut this, we will say do over here while with the semicolon. Don't forget the semicolon after the while in a do while loop. And the condition over here is while temp not equal to front. Okay, the condition will never be temp equal to null because there is nothing null in nodes. All of the nodes are pointing back to some other node. So n1 is pointing to n2, n2 is pointing to n3, n3 is pointing to n4, and n4 is pointing back to n1. So no null value is stored in the next pointers. So that's why the condition is while temp not equal to front, and we're using a do while loop because for the first time temp is gonna point to the front only. So we will start from the front node itself and we will go till the last, that is n4, and then again come back to front, and that is when we want to stop. So for the first time when temp is pointing to front, we still want to execute this loop, and then inside this the count will become plus plus and temp will become temp equals to temp of next. So in every iteration count will get incremented and temp will start pointing to the next point, next node. So this is something which is basic, we've seen previously. I'm not gonna waste some time over here. You can dry run it step by step by taking an example of you can take a queue with couple of nodes and dry run this code onto it. Take a pen and paper and keep a track of all the variable values, and at the end you will get count of 4 if you have 4 nodes, you'll get count of 3 if you have 3 nodes, and so on. Alright, so this is the count function. The only change that we did is we made the while loop a do while loop, and we changed the condition of temp not equal to front and not temp not equal to null. In the display function which prints all these nodes, Again, only simple change, the while loop becomes do while, because when you want to print all the values in the queue, you have to use a loop. We will again use do while loop. We will say do while, and that condition again has to be temp not equals to front. The printing is going to be as it is. We will say cout temp of key equal comma temp of data. Data is nothing but the value, and then the next node, and then we will say temp equals to temp of next. So initially temp is pointing to n1, which is the front. That is what we did over here. n1's key and data will be printed, then temp equals to temp of next, so temp will start pointing to n2. Then we will print again n2's key and data, then temp will start pointing to n3. Temp is still not equal to front because temp is pointing to n3 and front is pointing to n1, so they are not equal. So this do while loop will keep on executing and keep on printing the values as it is. Okay, so after you come outside this do while loop, what you can do is you can again print one extra temp of key and temp of data, because at the end temp will start pointing to the front again. So just to tell you that we are again at the beginning, because it is a circular queue, you can print this extra stuff and you'll understand what I'm trying to say when we execute this code. Right now I know things are a little cloudy because we have still to execute this, but these are the only minute changes that you have to do to make a simple queue using single linked list turn into a circular queue using single linked list. Now after this we have the main function, and our main function is nothing but a menu driven program. Again, a do while loop is used because initially we want to print the menu without checking the condition. These are the different options, so that's why we have an integer option. We will say what operation do you want to perform, and the user will input one option number. If user enters 1, it is enqueue, 2 is for dequeue, 3 is for isEmpty, 4 is for count, 5 is for display, that is displaying the entire nodes in the queue, 6 is to clear the command prompt, and we will take this from the user. If user enters 0, we will exit outside this do while loop. So the exit condition, if you scroll down, is while option not equal to 0. So when the option will become 0, this while loop will stop working. That is, this do while loop will exit and we will stop the program. Now these individual options that the user enters in the option variable, we will take from the user over here. We will say C in the option number. We will create a node pointer and an object on the heap memory using this syntax. So using this syntax, what happens is we create a pointer new node in the stack memory, but a new node object is created on the heap memory, and that address of that object in the heap memory is stored in this new node. Okay, and the reason why we are using this methodology is because when you create an object using this pointer approach, using this dynamic memory allocation approach, this object which is created on the heap memory will have global scope, and you have to delete that memory, that is release that memory manually. Otherwise, while the entire program executes and till you don't close the program, that memory will always be allocated and your variable will never be destroyed. It will have global scope. Okay, so that's the main purpose of using this methodology. You can see I have shown one more methodology in which you can create a node object, but I've explained in detail why we are going to do this in previous tutorial. So anyways, let's move forward. In the switch case, we are passing the variable option, whatever user enters 1, 2, 3, 4, 5 and 6. So we have 6 cases, actually 7 starting from 0. 0 is to break outside this entire switch case, because when the user enters 0, we want the program to stop. Case 1, that is when user enters 1, we want enqueue function called. We will ask the user to enter key and value of a node to enqueue in the queue. We will take the key and data from the user. We will say new node of key equals to this key that the user enters. So this new node is this pointer to the object that we create over here at the top. So we will access this object and we will access the key of this object using this syntax, because new node is a pointer, it is not a direct object, it is a pointer to the object. So when you want to access the data members and member functions of an object which is pointed by a pointer, this syntax is what you have to do. So we will store the key inside the key of this new node. We will store the data that we took from the user over here, C in data. Now this key and data are the two extra variables that we create on the top, you can see. And this is the queue object. It has to be circular queue. So circular queue, because we've made it circular queue, right? We've changed the class name. And the key and data is these two variables that we create, and that is what we are taking from the user, storing them in this new node object, and then we will say queue.enqueue and we will pass this new node. Now enqueue function has an argument of a pointer only. You can scroll up and you can see void enqueue. In the arguments, it is expecting a pointer. It is not expecting a simple variable. Node star n means that you have to pass a pointer of type node. And new node is basically exactly that. So if you scroll down again, you can see node star new node. Now the space in between doesn't matter. You can say node star new node or node star space new node. It is pretty much one and the same thing. So this is also a node pointer only, which is pointing to the object. So you can directly pass this new node and then that will be enqueued. Similarly, when you say dequeue function call, if you go to the definition of dequeue, you can see node star dequeue. So node star dequeue means that the return type of this dequeue function is a pointer of type node, and hence you can see we are saying return temp. So temp is nothing but a pointer of type node. So that's why we are returning that. Alright. So coming back to the main function in case 2, which is dequeue function called. This time on the RHS we have the dequeue. We say queue.dequeue, which will return a pointer, which will return an address basically to the node that is supposed to be dequeued, and that will be stored in this new node pointer. So this new node pointer will now point to the node that is supposed to be dequeued, and then we can easily access the key and data of this node that is supposed to be dequeued, right? Also we can also delete this new node. So when we say delete new node, when you dequeue a node, let's say n1 is dequeued, we have to also erase it from the memory because we've created it in a dynamic memory allocation way on the heap side. So when you say delete new node, the new node which is pointing to that memory location where n1 exists, that will be erased off and cleared off for other utilization. Okay. So it's always a good practice to delete the dynamic memory that you have created, and you have to explicitly do it. The compiler will not do it for you. We do not have garbage collection over here like Java. And that is the dequeue function. If the user enters 3, isEmpty function is called. We will see if queue.isEmpty, and in the if we are saying queue.isEmpty because isEmpty will return either true or false, and in the if we have to have a condition of true and false. So if it is true, that is if isEmpty is returning true, we will say queue is empty, else queue is not empty. Case 4 is for count function. We will say number of nodes in the queue and we will say queue.count. Now count function returns an integer value. So if you go to the definition, you can see int count. So int is the return type. We will return the count. You can see return count. So that we are directly printing over here in the count function queue.count. We will say number of nodes and we will say queue.count. Queue is nothing but the circular queue object. Okay, don't forget that. Case 5 is for display function. We will say queue.display. It is nothing but printing of all the nodes inside the queue, inside the circular queue basically. And case 6 is a system function call which clears the command prompt. We say system and inside that we pass CLS. This has to be as it is. It is just the syntax that you have to write to clear the command prompt. And then we have an extra default case in case the user enters some random number in the options. We can only have options from 0 to 6, right? So if the user enters 7, 10, 35, 60, we have to tell the user that the number that you've entered is wrong. So enter proper number, and again the do while loop will execute. Again the menu will be shown. Okay, so this was the entire explanation of the program, which pretty much I've reiterated because this is exactly what we did in the previous tutorial. So for those who have already watched that, this is a piece of cake, right? So the only things that you had to change was those minor changes in the function, and this becomes a circular queue now. Let's save this. Let's go to execute, compile and run. I hope things work. Alright, we missed out a semicolon. Don't forget that semicolon. Execute, compile and run. Okay, so our code is working perfectly fine. But let's see if all the operations of this circular queue works. I'm gonna hit first option number 1, which is for enqueue. I'm gonna say 1 and 10. So let's enter node n1 with the key of 1 and the value that is data of 10. Hit enter and you can see node enqueued successfully. So when I say option 4, which is for count, you can see number of nodes in the queue is 1. If I hit option 5, which is for display, now you can see display function called all values in the queue are 1 and 10, and it is again pointing to 1 and 10 because it is a circular queue, right? So the first node points back to itself, and that is what this extra printing in the display function is for. So that is what you can see, we wrote that extra line in the display function, this cout, which is again pointing to the first node, right? So anyways, let me just clear the screen and let's add one more node. We will say 2 and 20. Node successfully enqueued. Count is gonna be 2. You can see number of nodes in the queue is 2. And if I say display option 5, you can see now 1, 2 and again 1 and 10, which is the front of the node. So this is just for denotation purpose. You can remove it off. Like if you just comment this line out, then this extra node will not be printed. I have just shown it to you because it is a circular queue, right? So the last node, which is 220, should point back to 110 again. So that is what is depicted over here. Again, let's enter one more node, 330. Let's clear the screen and let's display. You can see 110, 220, 330. So every time you enter the node, it is entered from the rear end, and you can see this is the front and this is the rear, and the rear is again pointing back to 1 and 10. So this is the extra entry, which is just denoting that it is a circular queue using singly linked list. So now let's do the dequeue, and when we do the dequeue, the front value should be removed. So 110 should be removed. When I say 2, you can see dequeue function called dequeue value is 110. So it is removed, and now the queue should start with node 220, right? So if we do the display, which is option 5, you can see now it is starting from 220 going to 330 and again coming back to 220. So this means enqueue and dequeue is working perfectly fine. Is the queue empty now? If we hit option 3, it is false. So you can see queue is not empty when I hit option 3. So all these standard queue operations using singly linked list are working fine, and we are getting the proper results. You can go to our official website and check out this code. I highly recommend that you type it yourself. Even if you have the code right in front of you, don't just directly copy paste it. At least if you are doing it for the first time, please type the code once with your bare hands. By just looking at the code, that is also fine, but I highly recommend that you type this code once. Dry running the code would be even much more better to understand at step by step what happens. By taking diagrams also, you can draw diagrams with pencil on a separate sheet of paper. And yeah, this was the circular queue using singly linked list, which is basically nothing but our basic queue with a little bit of modification of code. And I've also tried to show you diagrams and visual representations with the differences. And we've successfully practically implemented circular queue using singly linked list. So if you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends. If you're new on this channel, definitely subscribe and check out the DSA course as well as many other tutorials that we've done on computer science and information technology. I'm gonna wrap up this video over here. Thanks for watching. See you in the next one. Peace.